Okay, so in this lesson we're going to multiply binomials by binomials. So that's a new concept for Math 10. You haven't seen this before. So we're going to start off with the area model of multiplication. So we're going to start with really basic numbers, 13 times 24. So 13 we can break into 10 plus 3. That's probably the easiest way we can break up 13, and the easiest way we can break up 24 would be 20 and 4. Makes it very easy to multiply. So what happens here, we have 4 quadrants, 4 boxes that we need to fill in. So we're first going to start with the 20 times 10. So 20 times 10 is 200. Oops, wrong pen. So 20 times 10 is 200. 4 times 10 is 40. So we're multiplying 10 times 4 to get the 40. Now we're going to multiply 3 times 20 to get 60 in this box. And last, to get the last box, that would be 4 times 3. 4 times 3 is 12. And then we add these all together. So 60 plus 40 is 100 plus 200, 312. Okay, so that's an area model, how we can multiply using the area model. And if you check in your calculator, 24 times 13 is also 312. Let's do the same idea. Why don't you try this one? Try 22 times 37. You can pause the video here. So you should have broken it up. 20 could be broken up into 20 and 2 is the easiest way. 37, 30, and 7. So that gives us our 4 boxes. 30 times 20 is 600. 30 times 2 is 60. 7 times 20 is 140. And 7 times 2 is 14. And so that would give us 600 plus 140 and 60 is another 200. So 814. You can check your answer. 22 times 37 is 814. Okay, so why do we do this? Well, multiplying binomials, we can also use an area model. And that area model is with algebra tiles, like these ones. So with algebra tiles, usually we use a box, a clear box, and the borders just show us what the dimensions of the length and the width are. So if we're multiplying x plus 3 by x plus 2, those would be my borders, okay, that I'm drawing. And I'm just going to use this thing. Let's get it to focus. There we go. Sometimes use a second to adjust. There you go. So you can see here I have x plus 3 and x plus 2, just like you have in your book. Okay, or you could also have the algebra tiles in front of you. They're on the side table to your left when you're sitting in the classroom. Okay, so this here, they're not included in this length and this width. They're not included in the area. They're just showing us the dimensions. And what's really cool is that we can actually fill in now what the area would be using an area model. So we first multiply our x times our x. And x times our x is x squared, which is the only tile that would fit in there nicely. Okay, now these guys right here, we're multiplying the x with the 1, and x times 1 is x, and they're all positive, so it's still positive times a positive is a positive. So you have 3 x's here. Okay, now again, down here, we're multiplying an x with a 1. That's the dimensions of this shape. So 1 times x is x, and there's 2 of them here. And then last, we're having 3 times 2. 3 times 2 is 6. So we're going to have 6 little ones, and they're both a positive 3 times positive 2 is positive 6. And what's inside is our area that's left over. Okay, so the inside, the dimensions, was x plus 3 by x plus 2. Our area would be the x squared, these guys right here. That's our answer. We have an x squared, we have 5 x's plus 6, and that would be our solution. So let's draw that on your piece of paper. So on your piece of paper, when you have an x times an x, that gives you an x squared. And if you have a pencil, you can shade it in. I usually use crayon. Where are you? There you go. So that was the x squared tile. Shade that that in to show that it's positive, okay? And then we have here x times 1. This is where we had our x's. 1 and 3 x's here. So you should always make a rectangle that fits together perfectly. And then our 1's. And they were all positive, so I'm going to shade them all in. There you go. Positive x's here. And then our 1's. So it does require some drawing. So our solution then would be x plus 3 times x plus 2 would be x squared plus 5x's plus 6. That was our solution using the distributive property. Okay, actually let's move this up here. There you go. Okay, so there's two other ways we can demonstrate this. One is distributive property, one's the chart. I'm going to show you the chart first before we do distributive property. So we're multiplying x plus 3 by x plus 2. So in a chart, I'm going to write, we have x plus 3 and an x plus 2. We're going to do this just like the area model we did before, which using Algebra Tiles was still an area model. So now we multiply first x times x, which gives us x squared. Then we'll multiply x times 3, and that gives us 3x. Oops. Oh, this out that way. 3x. And then the 2 times x is 2x. And then the 3 times 2 is 6. So we're multiplying each box. Now we collect like terms. So the only like terms are here on the diagonal. So that gives us, we have the x squared, 5x's plus 6. Okay, that's using the chart. The last method is using distributive property. So distributive property is an extension of the distributive property you learned last year in grade 9. The difference though, when we're multiplying by a binomial, x has to multiply by x plus 2, and so does the 3. And so how we're going to write this is we're going to write this x times the x plus 2, and then the plus 3 times the x plus 2, because both of them need to multiply by the x plus 2. They both need to be distributed into the x plus 2. Both of them. So that's the first step. That's how we write out the first step. So we have our x times the x plus 2, and then the 3 times the x plus 2. Okay, so now we can just go ahead and distributive property the x and distributive property the 3. So x times x is x squared. X times 2 is 2x. X times 3 is 3x. And 3 times 2 is 6. And then our last step is to collect our like terms, which again are in the middle, or is the diagonal in the chart. So x squared plus 5x plus 6. So they're all valid ways to multiply binomials. Okay, so let's turn to the next page, or look at the next page. So now we're going to look, so determine the binomials along the top and side of the diagram, then multiply them. So what are we multiplying here? So this dimension, we have an x plus 4. On our, I guess, length, we have 2 x's plus 1. Okay, so we want to multiply them. All right, so if we want to use the algebra tiles, you can just follow along or grab some algebra tiles. So let's change. So this time we have x plus 4 and then 2x plus 1. Okay. So in the corner we'll always go with the x squared because we have an x times x, which will fit an x squared. And down here, the only thing that would fit as well, x times x gives an x squared. That's its dimensions. Here, x times 1 is 1x. And then this side, okay, 1 times x is an x. We have lots of tiles here. 1 times x is an x. We have 4 of them here. 4 times x, 4 x's. And then the same thing repeated down below. Uh-oh. I'm shy 1 tile. 1, 2, 3. I'm going to steal one of the dimensions. Okay, so there's 8 of them there. And then down below are positive 4 times positive 1 is 4. So 4 ones. Okay, so this here is our area. Those were just the dimensions. This is our area, solution. So our solution would be 2x squared. We have 8 plus 1 is a total of 9 x's plus 4. There's our solution. So algebra tiles can be a great method for multiplying binomials. So let's draw this on your sheet, if you haven't already. On your sheet, here we have an x squared. It looks like a rectangle. It should be a square. Okay, and those are going to be shaded in because they are positive x squareds. Okay, and then we have an x here. And these sides would be 4. Another 4. And then last we have our 1s. We have 4 1s. And they should all be shaded. So you can use your pencil to shade them. One thing I used to do in my book to make it a little easier is a solid line was positive and then a hollow one was white. So just do a straight line for a positive and then a hollow line for white for a negative. You could do that as long as you can tell the difference. And then our 1s. The 1s are a different color because they're different. They're 1 by 1 dimension, right? Whereas the greens are x by 1 or x by x. Okay, so we have a total of 2x squared, 9x's plus 4. Okay, so that's using algebra tiles. Using a chart. So we had x plus 4 and 2x plus 1. So let's multiply. 2x times x gives 2x squared, which is what we had. You can see the 2x squared. X times 1 is 1x, which is why we had 1x in the bottom. 4 times 2x is 8x, is where we had 8x's on the side. And 4 times 1 is 4. And the last we collect like terms, which is on our diagonal there. So 2x squared plus 9x plus 4. Using distributive property, so here we have, x plus 4 times 2x plus 1. So if I'm using distributive property, I first need to multiply x by 2x plus 1, and then the 4 by 2x plus 1. Eventually, you want to always work with an algebraic approach, and the distributive property is an algebraic approach. All right, so x times 2x gives 2x squared. X times 1 is plus x. And 4 times 2x is 8x. 4 times 1 is 4. And then collect our like terms, which is 2x squared plus 9x plus 4. All right, very good. One more algebra tile example. You might want to try this one on your own first. You be careful though, because it has negatives in it. So this time we have x minus 3 times. That's an x minus 3 and an x minus 2 on this dimension. All right. So if you're setting it up, okay, so we have x minus 3 on the top, and it really doesn't matter if you do the x minus 3 on the top or the side. One of them is x minus 3, one of them is x minus 2. You'll get the same answer, right? Because if 3 times 2 is the same as 2 times 3, same kind of idea. Then we're going to fill this in. So x times x, that's where our x squared goes. Now, we have an x times a negative 1. So when you have a positive and negative, it equals a negative. So all of these here would be negative x's. Same with down here, because we have negative 1 times x is a negative x. Now what about the 1's? We have a negative 2 times negative 3. When the colors are the same, it results in positive. 2 negatives equal positive. So these would all be positive 1's. So let's draw that on our paper. So that's what you should have got. Okay? It's kind of hard to see because of the contrast with, if I turn off the light, see the 1's? There they are. There you go. Okay, so let's draw this. X times x gave us a positive x squared, so that will be shaded. There we go, good enough. Okay, so then we had an x times negative 1, so this was not going to be shaded, these guys. Same with these ones, 1 times negative 1 times x and negative x. And then we had negative times negative gives a positive. So these guys, these 1's, are shaded. Okay, so there they are. So that gives us, we can write our final answer. So the area is everything on the inside there. So we have positive x squared. We have minus 5x's, because there's negative 5x's, and plus 6. That should be our solution. Okay, so let's try the chart. X minus 3 and x minus 2. Okay, so x times x squared, negative 3 times x, negative 3x, x times negative 2 is negative 2x, negative 2 times negative 3 is a positive 6. And again, collecting like terms, which are on the diagonal, we have x squared minus 5x's plus 6. And last, our distributive law. X minus 3 times x minus 2. Again, it doesn't matter if you wrote x minus 2 times x minus 3 or x minus 3 times x minus 2. You'll still get the same answer in the end. So first we distribute our x. We want to multiply x by x minus 2, and then the minus 3 by the x minus 2. So using distributive law, we're distributing these guys in. X times x is x squared. X times negative 2 is negative 2x. Negative 3 times x minus 3x. And negative 3 times negative 2 plus 6. So collecting our like terms, we get the same answer in the end. Okay? Ultimately, it's up to you which method you use. If you're planning on going into Dash 1, you really want to get used to that distributive law and using the algebraic approach. On the test, you will see algebra tiles, so you need to be familiar with them. Okay, so turning the page, we have 3 examples left. No more algebra tiles. This distributive law. We have 3 examples to go through. Now, the first reminder I have for you is when you square a binomial, the biggest mistake I see is students think it's equal to x squared plus y squared. I'm going to square each of them. But remember, power law, we can't just apply it to both unless it was a product, but it's not a product. Those exponent laws don't work for addition. So that's not the same thing. So don't be foiled by that, okay? When you square a binomial, or when you square anything, it's the same thing as multiplying by itself. So x plus y squared is equal to x plus y times x plus y. So this example, x plus 4 squared would equal x plus 4 times x plus 4. Now, distributive law, we take our x, this x, we're going to multiply it by x plus 4, and then the 4 plus 4. Don't forget that plus sign. That's one of the biggest mistakes students make, is they don't put the plus or the minus sign, times the x plus 4. Okay, so now expanding here and here, x times x is x squared, x times 4 is 4x, 4 times x is 4x, and 4 times 4 is 16. And then our last step is collecting our like terms, which you'll notice will pretty much always be in the middle. 8x squared plus 8x plus 16. Okay, so let's try this guy. So distributive law, I'm first going to make 3s times 2s minus t, and then the minus 5t times 2s minus t. Okay, so now we can distribute. 3s times 2s is 6s squared. 3s times negative t would be a negative 3st. Negative 5t times 2s. I'm going to always write your letters alphabetically. So negative 10 and then st. And negative 5t times negative t. So two negatives equal a positive 5. T times t is t squared. And then we collect our like terms. So even if you had st and ts, they actually still are like terms, same variables, and they each have the same powers. Okay, so 6s squared minus 13st plus 5t squared. There you go. So you should try the next one on your own. Give it a shot. Pause the video here if you're trying it. So remember, you have a square, which means multiplying by itself. So using distributive law, first 4m will multiply by that second bracket, and then the negative 6n will multiply by the second bracket. So that's your first step. Now distributive law, each of these, 4m times 4m, oops, sorry, 16. 4 times 4 is 16, m times m is m squared. 4m times negative 6n, so 4 times negative 6 is negative 24, and alphabetically mn. They're not like bases, so we can't combine them. Again, negative 6n times 4m, negative 24, and then alphabetically mn. And last, negative 6n times negative 6n. Well, two negatives equal positive. 6 times 6 is 36. N times n gives us n squared. And so collecting our like terms, if you had 16m squared minus 48mn plus 36n squared, you got it right. There it is. Okay, so here's our homework for this assignment. And you're welcome to use the algebra tiles to help you through it, or a chart, or distributive law. And yeah, there you go.